All right, let's get right into it. It turns out the biggest story in AI right now, it might not be about the software at all. It's actually about a massive, kind of hidden physical crisis that's coming at us way faster than I think anyone is ready for.
This quote it nails it, right? We're not talking about some typical financial crisis here. We're talking about a fundamental resource crunch, a collision course between our digital dreams and our physical reality.
And this is the heart of the problem. This incredible, world-changing AI software has a voracious and very real appetite. It's hungry for electricity, and it's about to put a strain on our global infrastructure like we've never seen before.
You know, for years, we've all thought of the cloud as this magical, infinite, totally weightless thing. But the reality? The cloud is made of concrete and copper, and it consumes staggering amounts of energy. It has a very real, very heavy physical footprint.
Okay, let's just break this down on a really simple level. A single generative AI prompt, just asking one question, eats up almost 10 times more electricity than a standard Google search. Just think about that for a second. 10 times the power for just one query.
So, what happens when you take that 10x factor and you scale it across billions of users? Well, you get this number, a mind-blowing 160% projected jump in power demand from data centers alone. Our electrical grids they are not ready for this.
I love this analogy because it is just so perfect. We're innovating in the digital world at light speed, right? We're building these incredible AI supercars. But the physical infrastructure, the electrical grids, the roads they run on, is aging, it's fragile, and honestly, it's already pushed to the absolute limit.
So, let's look at how this goes from being a tech problem to a massive economic problem that's going to hit every single one of us. This isn't just about Silicon Valley anymore. This is about your wallet.
So you have to understand this key concept, energy crowding out. It sounds a bit academic, but here's what it means. As the big tech giants realize the public grid is getting full, they don't just stop building. No way. They use their billions to basically outbid everyone else for the remaining power, effectively cornering the market on electricity. And here's exactly how that plays out. The tech giants go out and lock in these huge long-term energy deals to power their new data centers. That means the slice of the pie left for the rest of us on the public grid shrinks. And you know basic economics tells us what happens next. When supply goes down and demand stays high, prices go up for everybody else.
And this is how it starts to get really personal. We are walking into an era where the cost to just keep the lights on in your house could be directly tied to some new AI model being trained hundreds, maybe thousands of miles away. It's a direct line from the digital arms race to your family's budget. So why are we honing in on one specific year? Because all the signs, all the projections are pointing to 2026 as the critical tipping point, the moment this insane digital demand finally smacks right into the limits of our physical supply. The clock is absolutely ticking.
I mean, we're on a clear collision course. The first signs of strain started showing up last year. But over the next couple of years, that's when the first wave of these monster mega-scale AI data centers comes online. By 2026, the whole system is projected to just hit a wall. Digital demand will simply overwhelm what our physical world can supply.
And the bottleneck isn't just about generating electricity. To build all this new infrastructure, we need a physical supply chain that's already stretched super thin. We're talking about unbelievable amounts of copper and lithium, and, this is a big one, these highly specialized transformers that you need to move power around.
This number right here just blows my mind because it highlights the core problem. You can't just code your way out of a physical bottleneck. The wait time to get just one of these essential transformers is now over 2 years. The digital world moves in seconds. The physical world of atoms moves in years. And that mismatch, that's the crisis.
And here's the potential societal fallout, which is honestly pretty scary. Big companies are already buying up old power plants, building their own private microgrids. We could be heading for a future where the tech elite have their own clean, reliable private power, while the rest of us are left to deal with an unstable, overloaded, and way more expensive public grid.
So, what does all this mean for the future? Well, this whole situation is signaling a fundamental shift in where value and where power is going to come from in our economy.
This really illustrates a huge paradigm shift. For the last, 20 or 30 years, our economy has been all about bits, software, algorithms, data. But now we're seeing the pendulum swing back, and swing back hard, to an economy of atoms.
the actual physical hardware, grids, and raw materials that make the world of bits even possible. And this means the next wave of wealth isn't just going to be made by the people with the smartest AI models. No. It's going to be driven by the people who solve this massive infrastructure crisis, the ones who control the land, the power lines, and the new energy tech that we need to power our future.
This quote is the perfect summary. We all love that saying, data is the new oil, but we always forget the second half of that analogy. Oil is totally useless without the massive physical infrastructure of rigs and pipelines and refineries. That's the part that's now under threat for data.
And so that leaves us with this final, critical question. Will our innovations somehow get us out of this trap in time? Or are we on a path to a future where energy isn't just more expensive, but maybe even rationed? The next few years are going to decide everything.